So we will continue class because we have less than 50 minutes. Where was I? It's gone? Wait, class. It's the answer that I got there. It's 0.0685 atmosphere for the answer. Why is it that I can't find my original whiteboard? Can't find it anymore. Oh, let me see. Okay, so it's not here anymore because we're done. So anyway, that would be the answer for number 2. Okay, the partial pressure of CO2 in atmosphere should be 0.0685. That way, it will not vaporize from the water solution. Okay, now we will continue with our slides. So that would be our sample problem number 2. Should you have any question, you can really uh, message me privately or in here or in our GC. Now, as for phase equilibria between different processes, so when we look into equilibria between a gas and the liquid, then that would be the equilibria that we have discussed in gas absorption and desorption. We're done with it last semester. And for this separation processes now, that would be in distillation. Okay, so this is gas liquid equilibria. If it's liquid liquid equilibria, meaning the phases that are contacted are both liquid in the case of extraction, then that would be the term extraction. So the equilibrium between the phases is what we call liquid liquid equilibria. Now, if it's liquid solid equilibria, so that would be in the case of leaching. So we want to leach out the solute in the solid matrix where it is contained, and that's in the case of leaching. And for gas solid equilibria, we also have what we call adsorption, which we will also be discussing. Now, part of module 1 will also be ending, just like what I have shared to you in the GC, will be ending on the concept of how we are to connect the concept of equilibrium with multi-stage process. So now there's a need for us to understand what's a multi-stage process. So this is also known as a cascade. So these are also known as cascades, and they consist of interconnected units or stages. So if you have a single stage interconnected with one another, then you have what we call a multi-stage process or a cascade. Now, each individual unit in the cascade, most of the time take note, receives two streams from the adjacent units to it. Phases in that particular stage are brought into intimate contact after the transfer has occurred. After equilibrium has been reached, these particular phases are again delivered afterwards to the same adjacent units. So it received two phases from the two adjacent units in which it is in between. Then it will, after equilibrium has been established, it will also give two phases to this same adjacent units. You will, I think, have a clearer picture when we are already on the specific types of separation processes. Now, the units may be arranged either one above another, or it could be arranged side by side. Now, in the case of extraction, it's in a column form. In the case of leaching, it's in the side-by-side orientation. So it could be any of the two orientation. Now, we'll still be using material balances. It's the heart of all our computation. So when we make material balances, it could either be based on the mole fraction or the mass fraction, depending on the type of unitary processes that we are studying. So most of the time, you're using both the total material balance and a component balance based on a particular component. Now, in the graphical method, we will only be tackling systems which has two components only. So we will be also learning, or you will be learning how to use the graphical approach for a two-component system. And this graphical approach or technique actually does not eliminate the concept of equilibrium, or does not even eliminate the material balance equations that you will also be using. So meaning, you use the graphical approach together with the equations that are provided. Okay? Although you can purely solve everything using analytical approach without having to base anything on the graph. Although at the last part, you will also be using the graph. Now, what about the concept of the ideal contact stages? Because these cascades are composed of this what we call ideal contact stages. So an ideal stage is the standard to which an actual stage is compared to. So in an ideal stage, usually we have a vapor phase leaving the stage, which is said to be in equilibrium with the liquid phase leaving the same stage. But this is not always the case, class. Huh? We can also have liquid phases leaving a particular ideal contact stage. But I will emphasize this, that only the phases that leave a particular stage are equilibrated. I think it's common sense because the phases that enters a particular contact stage needs first to have the phases contacted, reach equilibrium, and after equilibrium is reached, just the time that it's going to release the same phases at equilibrium already. So meaning the two phases are now already in what we call a state of equilibrium when they leave a particular ideal contact stage. So only the phases that leave an ideal contact stage is said to be at equilibrium. Now, since our design consideration is based on the concept of an ideal contact stage, when we design an actual equipment later on, we have to determine the actual stage that is. So in designing, there's a need for us to use a correction factor. This correction factor has something to do with what we call efficiency or stage or plate efficiency. That is if our column is made up of plates. Okay? Now, this is just a very fast discussion on the different separation processes and methods that we will be discussing here. So I just linked the two slides. So when we speak of separation processes, it involves the transfer of a material from one homogeneous phase to another. So a two-phase pair, which can be a gas-liquid, a gas-solid, a liquid-liquid, or a liquid-solid pair, could be the one that is being contacted. Now, the processing method could be single stage and multi-stage. So I think it's implied on how are we going to distinguish one from the other. So the two phasers are mixed in a vessel and separated either by batch or continuous process. In multi-stage, the two phases are mixed and contacted several times in a battery of equipments, either by batch also or continuous processing. So as to the types of separation processes, I will not anymore discuss the absorption and stripping because we have discussed this last semester. So that's for you to read. But we have distillation. This involves a volatile vapor phase and a liquid phase that vaporizes. In the case of liquid-liquid extraction, we have two liquid phases that are involved. In the case of leaching or solid liquid extraction, we have a fluid which is used to extract a solute from a solid matrix. So that's in the case of leaching. In the case of adsorption, so one or more components of the liquid or gas phase are adsorbed on the surface or on the pores of a solid adsorbent. So in here, we can also have ion exchange, or wherein ions are used to remove, or rather ions are removed by an ion exchange resin. So it's also a solid, by the way. Now, in membrane processing, so this is a separation of molecules through the use of membranes. We will look into the different types of membranes. Now, most of the time, these are very thin solid materials. They control, referring to the membrane, the movement of the molecule or of the molecules between the two phases. Okay, and this ends our module 1 for separation processes. If I can find time to record for the asynchronous process on Wednesday, then I will record and have it posted in our GC, not anymore in Canvas. if I can find time, that is, yeah, since our enrollment is still until Wednesday. Okay, any questions so far? So I am very fast, so I can dismiss the class probably 7 minutes before that time. All the requirements, how you're supposed to submit your solution, where you're supposed to submit your solution if you can't submit it in Canvas, are all detailed in the Canvas course style. But class, I'm so used to having prelim. By the way, that's just an example. I will edit it because in the example that I gave for the file name that you will need to submit, I use prelim quiz 1. We don't have prelim. We only have midterm and end term. So I will need to edit that for midterm and end term. So the example that I should be giving should be MQ1 for midterm quiz 1, and let's say number 2 or number 1 for number 1, then followed by your family name. That way it's easy for me to look for your answers. For the problems that will require answers, specifically those that are open-ended. Okay, any questions so far? After this, we'll go to a very interesting topic of distillation. It's the lengthy of all separation processes. But you will love distillation because it's really very detailed, even the manner in which we're going to design the distilling column. Okay, it's very interesting. And if you're going to work in the industry later on, a distilling column will be the most common equipment that you will find in the industry. Any question?
Hi, Miss. Good afternoon, Miss.
Yes.
Kay may sa Canvas na regarding may sa quiz sa Wednesday.
Yes.
Amo ni siya, Miss, ang discuss mo, Miss, nga
Ha,
face
amo ni siya. Ha.
equilibria.
Amo ni siya.
Okay.
Oo. Hmm. So meaning on Wednesday, thank you for bringing that up. On Wednesday, you will have to, it was discussed in the orientation that you will have your quizzes here video on. So meaning I need to see you while you're taking your quiz. Now, if there are some of you, hopefully none, who will find it difficult to really open their videos during the course of the quiz, you can message me privately. We'll discuss on what we're going to do in your case. Okay? But for those who can have their videos on, video should be on in my subjects, in all my subjects for this semester, during the quiz and during the exam.
Miss, last na lang, Miss.
What question?
Conceptual lang, Miss, or may problem solving man?
My problem solving, syempre it's comparable to the one that I have given you. Di ba naghatag man ko do assignment, no? Nga do i-process nyo.
Miss.
Do inyo na siya nga, do amo na siya inyo, do review, mas naging discuss ko. But the problem that I will be giving will not really deviate much from what I have discussed and what I have required you to read. And based on what I have required you to read, it's self-explanatory man kung paano to siya sulbon. Relative volatility lang to siya galing. But nonetheless, it would still be using the partial pressure ratio. And that is the pure vapor pressure ratio. So it's easy. Ara naman sa table. But since you brought that up, you have to, by the way, make sure that you have your Henry's constant table. You know where to get it. And you have the tables that were given to you in the first module that I uploaded through GC, the one that I will be submitting in the office. So, kinahanglan kung ano siya nga mga table, kinahanglan nyo kuhaan sa data, ni ara na ka mo na available because you'll be using it in the quiz. You have a very easy quiz and done already with the quiz. I think I even have it already locked only. Like it's done already. But it's, if I'm not mistaken, it has only 2 simple problems and 10 concept questions. The problems will require you to submit, to upload your solution in Canvas or through the link that I have provided if you cannot submit it in Canvas. Have more questions? Still 5 minutes? May 5 minutes pa? None? para wala tasang may mabilin nga topics sa introductory concepts and principles before we go to distillation. Kay karon do exam na ina siya nga ma-quiz ako sa distillation, may quiz pa ko yung, may topic pa ko nga naka-include sa phase equilibria. Okay, so if there are no more questions, subong wala pa ko may madumdumang yung questions, maybe later you will have some questions, just message me. Okay? Okay, no more question? Sige. Bye for now, everyone. Thank you.